G'day guys, welcome back to the channel. In this episode, we're tidying up a few loose ends for the 4-link in the Coiled, Colorado. All right, we're going to pick up where we left off in the last episode. If you didn't get to see it, I'll put a link up over here or here and you can go back and watch it. Basically where we finished up there, we were trying to adapt the ABS sensor from the Colorado into this 80 series housing. So we're going to do that today. We're going to go through, make a tow bar, mount the fuel tank and probably straighten this diff because we've done a lot of welding to it. Now at the end of the last episode, I was showing you the bush I was going to get machined, or a price for machining. The price came back a lot. It was going to be, you know, about $1,000, $1,500 to get those two little bits of steel made. So I've had to have a rethink and a redesign, and I think I've come up with a better solution that's going to cost nothing, free, bit of scrap steel if I've got some floating around. So we'll dive into that and I'll sort of show you what my current plan is. In case you missed the last episode, just a quick recap. This is the RC sensor, the RC Colorado rear ABS sensor. This is the 80 series diff. Along here we have the tone wheel, and we basically need to make this sit about 2 mil off this tone wheel, hopefully, so it'll work as factory. So the original idea was to cut a section out of here and weld a bush in. That bush is going to be too expensive. So the new idea I've actually got, because this thing is so short, I will be able to drill a hole at this mark here, and I'll be able to essentially grind out a little bit of the edge here, so this will slot in. It needs about 8 mil of spacing from this flange face to sit and get about 2 mil clearance free of that tone wheel. So I'll be able to do that with about an 8 mil plate, TIG weld it on, probably put a little bit of some sides on it just so it can't rotate or move maybe, but it should be a very cheap and easy way of doing it compared to my original idea. So let's get into that. So those are our little mounts essentially for the ABS sensor that we're going to be using. I didn't have any, it needed to be 8.5 mil on the end to sit at the right depth. I'd rather it be a little bit further away than too close because I can always shim it in a bit closer if I need to. But 8.5 mil was the measurement we had. Obviously they don't make 8.5 mil plate. I had some 8 mil, too small. 10 mil I didn't have any floating around, so I actually had to cut a bit of 40 mil solid bar and cut it down to about 9 mil. And then I flattened it out on the linisher. So we've got 8.55 mil at the moment, so it's pretty close. That little 5 mil hole there I've drilled, that'll get tapped out to 6 mil. And then it will be able to, basically I'm going to take this hub off now, get it sitting a little bit too far away from where this runs here. So that will, it's going to be a bit hard to show, but that's going to sit there. We don't want it to be sitting too close to the hub where it spins, otherwise it'll get worn through. So you need a mil or so off here. So it's a bit finicky, but I need to essentially get it sitting so it can't, if the bolt comes slightly loose or it gets a bit of vibration, it can't fall down onto the hub. So I'm going to pick it up a little bit too high drill and tap the flange, weld this little adapter in place, and then slowly just die grind my way down so where it sits is about 1 mil clearance and it can't physically go up further, but it'll be sitting hard against the adapter in the steel, and that'll be fixed. So we'll Loctite the bolt on, and hopefully that will work. If it doesn't, it'll be plan B, but this is looking like it should work. Because of the way I'm mounting the ABS sensor, the handbrake setup for the Land Cruiser axle is going to have to go, which is probably a good thing. They're not well known, or I should say they're pretty well known for not working very well. So I'm going to do a transfer case style handbrake using a mechanical caliper. I could have done like 2 calipers, like mechanical calipers on the axle as well, but I've just decided to go this way just for something I've never done it before, so I'd like to give it a crack. So yeah, we're able to pull all this apart, take all this brake shoes out, all those bits and pieces, and then sort of clearance, probably even take the dust cover off. We don't really need it. For me, it just holds mud and rocks in the way, makes noises, that sort of thing. So I don't really like keeping them if I can avoid it. So we'll get rid of all this stuff, and basically all we really need out of it is the heavy duty bit in the back here, which just mounts the caliper to the axle. That is the ABS all set up there now. So you can see I've got a little bit, maybe in the small camera, you can see a little bit of clearance just on the ring, and it's about 2.3 mil away from the tone wheel itself. So that might be a little bit too far away. I might need to shim it in a little bit. The factory, like this sensor was right on 2 mil away from the tone wheel, but I'll run it like that for now and see how it goes. If it needs to be shimmed out in the future, I'll do it then, but I think it's better off being a little bit too far away than too close, because you don't want it to hit, obviously. I'll go to the other side now. You don't need to see that. It's going to be the same process. And then we'll move on to the next bit. Next step is to check this housing for straight. I watched a really good video a few months ago by Matt Kinsella from Kinsella's Customs, where he sort of went through and sort of explained and showed how welding will distort a diff. No matter if you go slow, fast, to some degree, you're going to probably bend the housing. So I want to go through and check it. I'm going to go through and pretty much do the same method he uses. I did see, he didn't actually show in that video how to do it. It was a future Tyler Thompson video, I think, where he showed how to straighten the housing. But what we're going to do here is essentially make 2 pucks that will sit where the carrier bearing sits, drill a hole on the lathe to take 35 mil rod we've got here. I'll clean up, and then I'll bolt these carrier pucks into the diff, slide the rod through, and then you'll be able to eyeball and see how far out it is. But yeah, strip this apart, mark the bearing caps so you don't get them mixed around. They are sort of matched to each other. All right, so that's the pucks finished. They've turned out pretty crappy, really. I'm not the world's best machinist. I always have seen a problem with a parting tool. I tried a new parting tool then, and it just did not want to play the game, even on aluminium. So I don't know what I'm doing wrong there. I might have to do a bit more YouTube research on how to use a lathe properly, but they will do the job. So we'll put these in here. One's there sort of half started already. And we can throw in the diff and see how straight it is, or not straight it is. this is the setup here. It's probably not the safest way to do it. Watching the video of Kinsella doing it, he had a proper I-beam, they could wrap a chain around and it was probably a lot safer. I don't have that. So what I'm gonna do is actually weld this chain to the bench in a couple of spots and hopefully that'll hold. It's a 12-ton jack. So basically this is gonna get pinned down here. The jack will push up. I'll put a bit of heat roughly where this brace ends on both sides, because you probably won't bend it back where the thick bit of brace is, and we'll hopefully get it straight. That's the diff straight now. That took quite a lot of heat. Do not bother with MAP gas. You might have seen there I started with the MAP gas bottle. By the end I was using the oxy. I went up to a mate's place and grabbed his oxy set and did it with that. And even then it still took a lot of heat. So forget about trying MAP gas, it doesn't work. You need a proper oxy. But it is there. I didn't bother making an end puck to sort of line. I just used some window packing shims to sort of hold it in place and sort of confirm it. It's not 100% perfect, but it is pretty good, a lot better than what it was. So now I just got to cut these chains off. Nothing broke off or snapped or hit me in the face. There was quite a bit of load there, so that's a win. We'll move on to the tow bar now. So we'll make all that up and then we'll be able to mount the fuel tank as well. We've had a bit of a drama. As I was pulling that diff out off the bench, before I cut the chains off, or cut one side off, before I cut them off completely, I pulled the straight bar out and it didn't feel right. And as I was pulling it, I looked at it and the straight bar isn't straight. Now, I did check it before it went in. I sort of eyeballed it. It looked straight to me. And as I pulled it out, I eyeballed it again and it didn't look straight. So I've got it set up in the lathe here. I'm going to basically spin it slowly. I'm not going to run the lathe. I'm just using this to spin it with the dial indicator here to find where the high spot is here. I'm going to heat basically back where the bend starts. I've found the bend where it starts to bend on the bar here. And I'm going to put heat there, use the lathe to sort of push it back to straight, run the dial indicator till it's really, really close, and I'll check that diff again. So hopefully it's not too far out. I don't have to start all over again. I think it must have just bent from the heat I was putting into the diff. That's the only thing I'll put it down to. I've gone through and got that round bar straight. It's not 100% perfect, but it's pretty close. It's within a mil probably, the bar itself. I've run that back through the diff and it again is not perfect, but it's not touching on any of the edges. It's running in, so it's probably still a mil or two out, but I think that's about as good as I'm gonna get it with my probably skill and tools I've got here. So I'm happy to run that. I think it'll be fine. It's obviously, if it's bad, you'll still get uneven tyre wear and that sort of thing on the inside or outside edges, depending on how it's bent. But in this scenario, and for the purpose I'm going to be using this car for, I think it'll be fine. So I'm going to run that. Okay, so moving on to the tow bar now. Now the tow bar needs to happen before we can mount the fuel tank, because the fuel tank will mount to the tow bar. It's not something I've seen done before, but I can't see an issue with it, neither does the engineer. So as long as, it's when you go to remove the tow bar for whatever reason, you'll have to prop the fuel tank, which is not the end of the world. But so once I make up this tow bar, I'll be able to also mount the fuel tank. And then all I've got to do is make some links and we're ready to final fit everything, paint everything up and put it in. We're getting pretty close. That's where the fuel tank's going to sit there, more or less. I've gone a different sort of mounting method to what Ironhide usually does. I'm using these across the front. I've obviously got to drill a hole in these yet. 3 of these across the front to pick up the 3 front holes. 3 of these welded to the tow bar underneath, obviously with a hole in it, to take the 3 back holes. That should make it a bit easier to actually install when you need to, because you'll be able to sit the back mount on these tabs, which will hold it in place, and just be able to bring it up, put 1 bolt in, and it'll be suspended, it'll be held in place then. So that's the tank all mounted now. I'm going to go through and weld out this tow bar. Obviously got to weld the fuel tank brackets on fully, and I'm going to add a lot more gusseting to this tow hitch. I haven't welded across the horizontal face here. It's just a theory I've got just from trailers. So when you weld a trailer up across the front of the drawbar, you don't weld across that horizontal face where it meets the front cross member. It's the same sort of theory here. I think it's probably going to create a weak point and create like a heat affected zone and it potentially fatigue across there. I think with the amount of gusset I'm going to add to it, I don't think it's really going to matter, but I probably don't really need to weld there. So I'm going to add, I just had these brackets laying around. They were just from an old project that I didn't use or whatever, just laser cut stuff. I just have a box full of that sort of stuff floating around. And they're going to be ideal for this project. Sit them up there like that. You can even fit the chains in there if you need to. I've got some more little ones that I'll put down the side to give it some more stability that way. And I've got this old chassis fish plate that I'll put across the back. I'll notch around the fuel tank mount and around the back of the hitch as well. So it'll give a lot of stability, a lot of strength, and it shouldn't go anywhere, and the engineer should be happy, hopefully. So we'll get into that, and then we can mock it all up. Put the axle back on, and I've got to find out how wide I can make this sway bar.
I just bought this receiver hitch off eBay, and it's like every other tow bar I've ever had. The end cap that comes with it is just tack welded on the corners, and every tow bar I've had has pretty much started rusting around this end cap because it's not sealed up properly. So I've decided to TIG weld all the way around the inside and the outside to essentially seal it up so it doesn't rust from the inside out. Hopefully make the tow bar last a lot longer.
Okay, that's the axle back in. I had to get the axle in before I could finalise these bump stops. I just went through and smashed that out. You've probably seen me do stuff like that before, so I didn't bother showing you, but I had to basically cut a little section in to make this where the pad mounted flat, because where it's designed to go would be 150mm further forward because we've moved that axle back. So it wasn't landing on a flat part of the chassis, so I had to make a flat part for it essentially. That's it for this episode. Next episode, I'll be going into the sway bar, brake lines, fuel lines, wiring, that sort of stuff to make everything work again. So tune in for that. Thanks for watching. See you then. Cheers.